Objective 2 is going to require you to know the following. Here's your description. Describing and graphing linear equations, inequalities, and systems of equations. They like on the test, they like to refer to slope as rate of change. So if you see the word rate of change or slope, you need to know the meaning and know to use the best accurate approach is using the formula. That is on your formula chart. Is two representations, one with the graph and one with the table. All right, so what is the rate of change for the graph below here?
Oh, okay.
All right, so you have to calculate the rate of change if they give you the graph, which means the same as slope. So I'm indicating here that you want to use your formula. In order to use this formula, you have to have points on the graph or in the table. So you need to find two physical points that you can use. There's more than one, so just tell me which one you want to use. 212.
And then 46.
All right, 4, 6. Okay, so remember, these are our x1s and our y1s. We're just plugging that into the formula. M is our symbol for slope. So what values go on top using the formula?
6 minus -6. The 6?
Yeah, 6 minus 12 on top, and then what would go on the bottom?
6 minus...
4 minus 2.
4 minus 2. Okay, good. All right, so we're just simplifying this. Okay, this would give me -6 over 2. Yep, that is our answer. Okay.
That's just it.
Yep. Now, the reason why I want you to do that instead of using rise over run, guys, is like, if let's say I started at the y-intercept. If I go down 1, 2, 3, the slope of -3 would be 3 over 1, right? -3 over 1. And then move over 1. Am I hitting the line? No, because it's not the same scale. That's why using the points is the best way of getting your solution. So make sure you use the points. Okay? You just need 2 points to get to your rate of change. All right, so what about the slope or the rate of change? What's the rate of change of this table? Okay, same thing. We need 2 points. Well, 2 points. Yeah, it doesn't matter the points. We can do 0 and 35, and then you can do 4 and 25. Okay, if you don't want to mess with the decimal, you can go to just the whole numbers. But you got to remember, in your table, it's just x comes before y. So the first set of numbers are your x, the second ones are your y's. All right, let's see if you can get to this rate of change.
The 0 thing fell to the x and y.
Yeah, this would be my x1 and my y1. Yeah, the first one. So if I'm using the formula, y2 minus y1. Yep, you're doing the y's on top. No. Yeah, it's a decimal answer.
So y is going to be 25, right?
Yes.
-5 over 2.
Oh, never mind. And then it's going to be 4.
Wait, why is it 25? I thought it was 25. 25 minus 25.
It should be the same answer. It comes out to be the same. It comes out to be the same answer. Yeah.
It's not 25 minus 35.
Okay. Okay. I'm gonna do 25. Okay.
I thought order mattered.
Yeah.
Never mind.
Yeah. Wait, 10 over 4? Yes, 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 yes. When you're doing the difference, you have to do the same difference. If I'm changing the difference between this point to this point, then I have to go that to that. Like, I'm just saying your difference is your rate of change. The difference in the x, the y coordinates over the difference in the x
Wait,
coordinates.
so it would be negative 10 because 25 minus 35 is negative 10.
Sorry, negative 10 here. And this was positive, yeah. So it's a negative 2.5. Are we okay? Or negative, yes. Or the negative 5/2. Yes. You can have either or. Sometimes they give you a decimal answer. Sometimes they'll give you the fraction. All right. So now, of your linear equation forms, guys, make sure you're familiar with slope-intercept. That's on your formula chart, y equals mx plus b. Of that, you need to know your slope. Your m is your rate of change. Your b is your y-intercept, or the beginning of the beginning amount, or the beginning of the graph. Then you need to be familiar with point-slope form. They're going to ask the application of this form in objectives 3 mainly, not of 2. Okay. And then standard form. Definitely standard form, because most of the time your answer choices will be in standard form, but in order to graph, it has to be in slope-intercept form. So this being able to solve for y is what's the most important skill that they check for, that you can apply that skill by isolating the y term. So to isolate the y term, you want to do the opposite sign of x first to eliminate, cancel the 0 pair. And then you're going to divide by the number in front of y. We want it to rewrite so it's mx plus b. This is a form that you can type in the calculator, and this is a form that you can graph. All right, so if we look at our example here on the next page, they want us to graph 2x plus 3y equals negative 6. It's not in the form that we can graph it in, so what are we going to need to do first? Yeah, subtract 2x first, and then you should rewrite. All right, so 3y equals negative 2x minus 6. Yeah, divide each term by 3. Yes, bless you. So now the 3 coefficient cancels. Yeah, there's our equation. Okay, so in that equation, we should be able to read the slope and the y-intercept. What's our slope?
Negative 2 over 3.
Negative 2 over 3. What's our y-intercept?
Negative 2.
Negative 2. Or you can look up at the point as 0, negative 2. Okay, so if I'm graphing, to help see the x-intercept, I need to see the graph, the actual line. Where do we start to graph this?
Negative the y-intercept. I mean the y-axis.
Yeah, y-axis is negative 2. The y-intercept, which is negative 2, is on the y-axis at a negative 2. I got that. Okay, so now how do we move from this point?
Down
Down
to the right 3.
to the right 3.
1, 2, 3. Yes, put a point there. Down 2 to the right 3. Okay. Or I can count up 2 to the left 3. Okay. Huh? Yeah, you get a ruler so you can get your straight edge. All right, so we're putting a line through these points. Okay. And now, seeing the graph, I can see my x-intercept. Yep, it is the order pair negative 3, 0. Yep, the 0 is your negative 3. All right, so your 0, remember, is also your solution. Okay. Okay. 0 and solutions are the same. So it's where we're looking on the x-axis, find that x-intercept. All right, so from going to one line, they're going to ask you to do the inequality as well. So if you look, make sure you know these symbols. Make sure you know the solution is the shaded. So this is just kind of giving you examples of each. I would say memorize these parts. Know that if it's a dash line and I see this symbol greater than, I'm just gonna get my crayon here. We need to, you can darken it if you need to, shade above the line when it's greater than. Whenever I have the line in the inequality, which is this line here, that's equal to, including the equal sign, that's why it's a solid line. No, if it doesn't have the line, then it's a dash line. If it has it, it's solid. And then we're shading above because this says greater than. Okay. Yes. Vertical line, then greater than would be to the right, less than would be to the left. Yeah. So if you have a vertical line, and let's say it's dotted, okay? If the inequality says greater than, less than, it's pointing to where you shade. So this is pointing to the left. So you would end up, for a vertical line, shade this section. If it was greater than numbers to the greater than or to the right of the number line. Okay, that's a good question. Same thing with horizontal. Let's say if you had a horizontal line. So that means the slope is 0, right? Let's say this is on the X and Y axis. We got that? All right, yes. Not yet. So if I'm doing greater than, where will we shade? Greater than would be to the top above, right? If I was doing less than, that would be below. Okay. All right, so make sure you can do your shading. You want to do your shading probably on your own paper. Like on the online version, you get to click the region where you want the shading to happen. Okay, so make sure you do one at a time as well. Do your line first, then do your shading. Otherwise, it might mix the two actions. All right, so this is a part we need to memorize. Don't forget this rule. Symbol switches direction when you multiply or divide by a negative number. Okay. When you multiply or divide by a negative, our symbol will switch directions. All right, so let's look at this next example on the next page. I'm putting it all together. All right, graph 4x minus 2y greater than 8. Graph this inequality.
Make it into the y equals mx plus b.
Yes, we need to make it into this form. That's exactly right. Okay, so to do that, minus the 4x, good.
Can it do negative y is greater than negative 4x plus 8?
Yes.
And then we divide everything by 2.
By negative, yes. Okay, because we're dividing by that negative 2, I'm just going to write it to the side here. Yep, you flip the symbol, so it's now less than 2x minus 4. There we go. Okay, now, so we're going to graph this so we can determine our solution set. Where do we start to graph this?
4 on the y-axis.
Yep, negative 4 on the y-axis. Put that point. Then how do we move from this point?
Up to
To the right one.
To the right one.
Or,
Yeah.
yeah.
Timmy, how are you looking?
Because it's funny.
Okay, what type of line do we have here? Yeah, it's a dotted. So I'm just going to put dashes in between. Okay. Just put little dashes in between our line and our points. All right, now for our shading, where are we going to shade?
Below.
Yeah, below. Okay. Because it's less than. There we go. All right. All right, so now they want us to check our solutions, our points. So the first point they asked is 4, 0. So I'm going to plot that point. There's 4, 0. Is that a solution? Yes, it's in the shaded. Is 0, 0 a solution? All right, good. Now, let's say you don't get the graph. To solve algebraically, to prove algebraically, it's not a solution. You have to plug in the points. for your x and y. Remember, your points are a coordinate, x and y. So if I have the inequality, this is what we have, y, oops, I meant to do that in blue. Sorry. This inequality we have box right here, we had y is less than 2x minus 4. I'm plugging in 2 for x, okay, 1 for y. That's all I'm doing. Anytime we plug in, we use parentheses, okay? So parentheses, minus 4. Okay, so inside here, we're putting our 2 where the x is, our 1 where the y was. And then we're determining if the inequality is true or false. We're just going to do order of operations. So this is saying 1 is less than 4 minus 4. What's 4 minus 4?
0.
Okay, is 1 less than 0? No. So this is false. Y'all remember what happens when we get a false statement? Yep, no solution. Remember that symbol? Yeah. All right, so this, I would start this example because this is how the new style question is on STAAR. What they'll do is they'll give you the line in standard form, and they want you to determine the points that are solution sets for the inequality. So because we're talking about an inequality, we still need to solve this for y. So what would be our step here? Yes. So when I do that, what's the new inequality?
-1 is greater than or equal to -3x plus 1.
Yep. All right, now can I keep a negative variable y here? Yep, divide everything by -1 and flip this sign. So y is now less than or equal to 3x minus 1. So think about that. If this is now the inequality, where would that shading be? Yeah, it would be here below, right?
So
All right, so it says select 3 points that are solution sets.
the one on the line and the 2 that are in.
Yep, the one on the line and the 2 in the shaded. Yes.
But it's only that one if it's like solid. Like
Yes, only if it's solid can you pick a point on the line. Yes. Yes. Okay. So that might be another note right here. Okay. Dash line. Oh, sorry. Sorry. But this is not greater than or equal to. No. Yeah. Points on a dash line are not solutions. Just remember that. It only works for a solid line, not on a dash line. All right, so from lines to inequalities, now we're going to talk about systems. Okay. So remember, if I see systems of equations, look at the graph to find the solution. The solution has to be an intersection.
Systems
Okay.
are very fun.
Okay. There are 3. Oh, that doesn't look like a 3. Let me fix that. There are 3 types of solutions. Oops. Yeah. Yeah. Not 3 types of slopes. There's 3 types of solutions. That's slopes. I gave you an example.
One solution, no solution.
Yes.
Oh, okay.
Not right now.
Infinite, no solution, and one.
Yeah. Yeah. Here we go. So there's our types. Yeah. Yeah.
I said it first.
Okay. If it's one solution, this is an example. We have to see an intersection point.
Yes.
So the solution to this system is that point right there, -3, 1. All right. So to have one solution, there has to be an intersection. That's the intersection point. All right, now, if it's no solution, that means the lines don't intersect. They're parallel. So this is our symbol for no solution. This happens when we have parallel lines, which means they have the same slope. So anytime I see an equation that has the same slope, then we're going to have no solution. Now, infinite solution is like saying this is the first equation, and then when I graph the second one, it's right on top of it. So it's the same line. Yeah, and there would be infinite, or you could say all real numbers. All right, so this example is just showing you the calculator trick. See if you remember that. You would have to type in y equals 5x plus 1 first in the calculator. The second one, we need to solve for y. So how would we do that? Yes. Nope. All right, so there's your second equation, right? So they typed it in for you. These are the notes to show you. You have to hit second, trace, then 5, and enter 3 times. You might want to physically practice, guys. Okay, good. Thank you, Timmy. You need to do these steps right here. Second, trace, 5, enter 3 times. Yeah, yeah. All right.
They're being really funny right now.
Okay, so think about this, right? The solution is where they intersect, right? So this is where we have a solution. Now, that means this 0.16 is on both lines.
Yes.
They exist on both lines. All right? I say that to help you with the table. Okay? Yes. The answer for the solution and when the table it's this one is 3, 4. Yes, it has. Remember, I just said this point is in both lines, so it would have to be in both tables. So you want to find the point that's the same in both tables. You need to look for the point. Yeah, that was the same point in both tables. Okay, so this would be 3, 4 for this one. All right, so system of equations, 2 lines, okay, to system of inequalities. All right, this is going to be, and then we'll talk about transformations real quick. But so if I'm talking about systems of inequalities, obviously we have to see the inequality symbols. But now we're looking for the overlapping shaded region. I did give you an example of what that looks like. Okay, I know yours is not in color here, but when we did this, we made a big capital S to show where the overlapping region is. That's where the solutions have to be. The points have to be in that region for it to be a solution, sorry. Okay, all right, now let's graph this one, this example. The first line here, inequality, we can graph because it's in slope-intercept form. So we start at 4 on the y-axis. How are we moving from this point?
Up 3 to right 1.
Okay, so can I move up 3? No. So what am I gonna have to do? All right, so we're gonna go down 3, 1, 2, 3, left 1. There we go. Down 3, left 1. All right. What type of line are we gonna have here? What's
solid line.
yeah, solid line. Okay, solid line. And we're gonna shade because this is less than or equal to. Where do we shade here?
Below.
Yep, below. Okay. All right, just shade below. Okay. All right, now for the second inequality, this 2x, sorry, 2x plus y less than, this is not in slope intercept form. What are we going to have to basically do? Yeah, how are we going to solve it? Okay, all right, so basically I'm moving this 2x over. So y is less than negative 2x minus 1. Okay, so this, oops, this is our second inequality. Where do we start this graph? Negative 1. And how do we move from this point? Yeah, down 2 to the right one. Good. Down 2 to the right one. Or up 2 to the left one. All right, and then what kind of line is this going to be? Yeah, dash line.
Oh.
All right, and then our shading, where would the shading be? Yeah, it's less than, so it's below. And then we're looking for where they overlap, right? So really, I'm just focusing in this, oops, where's my triangle? This triangle is the overlapping region. Okay? So you might want to, you don't necessarily have to shade this part, but you do have to get that triangle to show the overlapping. Okay? It's just up to you. Oops, sorry. All right, so you could put, oops, where am I at? There you go. You could put just a big S there to show where the solution set is. So I'm just put a big old S here. All right, so answering our questions. Is negative 1, 0 a solution?
Yes.
Yes. Is negative 1, 5 a solution? No, it is not. All right, to prove algebraically, no, it's not in the overlapping. It's up here. Negative 1, 5 is up here. All right, so for this one, you would have to, oops, you would have to plug into both equations. You would substitute, I'm going to abbreviate, 0, negative 3 for your x and y in both equations. In both equations. So I'm just substituting in those values. So like for the first equation, this would be negative 3 is less than, what's it less than? Yeah, less than or equal to 3 parentheses x, which was 0. And then we had minus 1. No, plus 4, sorry. Wasn't it plus 4? Yeah, plus 4. It's the first one. All right, so really, this just becomes 0. Is negative 3 less than or equal to 4? That's true. So it works for the first one. So we got to check the second one as well. Negative 3, because now we're doing y is less than negative 2x minus 1. Okay. Well, anything times 0, 0 is negative 3 less than negative 1. Yep. So it's true for both. So it is a solution. Yeah. All right. So what would no solution look like if I had an inequality? Parallel lines, but what would the shading be?
They would overlap.
Huh? It wouldn't overlap. So that means you would have shading here and then shading over here. Because to have no solution means we have no overlapping. So no solution is the region here. Okay, so here is just the descriptions of the different types of transformations. Like if anything that's dealing with a translate means a movement up or down or left or right. So if I'm adding after the variable, then that's vertical translation, which means basically it's going to go up or it's going to go down. If it's subtraction, it's down. If it's addition, it's up. Okay. Now, if the adding is inside the parentheses, see this one has parentheses. This is horizontal transformation. So if it's minus now, I'm moving to the right. If it's plus, I'm moving to the left. I say that for our first two examples. If you look, f of x equals x. This is the parent function. Okay? So like if I wanted to use my calculator to help, I would say y equals x. Put that in your calculator. Oh, it's in there already. So x graph, that goes straight to the origin. All right, so on this next one, g sub x is 3 times f of x. Well, f of x, what was this representing? It's representing an x. So we're saying 3 times x, the minus 2. This would be my second one. And so here's what's happening. Anytime I'm multiplying, that's a dilation. Like I'm going to underline this 3. Underline this 3. Because the 3 is multiplied to the front of the function right here, and it's greater than 1, this would be a stretch. Okay? Because I see outside minus, minus, anytime I see minus, which is right here what I was talking about, this means I'm going to shift down 2. So if I compare the two, I'll put the second one in. See, here's the y-intercept right here was at 0. It did shift down 2. I can physically see that. And it went up steeper. The slope stretched up. Okay. All right, so here, whenever the multiplication is inside the parentheses, that's when it's a horizontal stretch. So if I look, there's a negative sign outside this f. If I see a negative sign outside the f of x, that's a reflection over the x-axis. So the first thing I see, I'm just put reflect over x. The next thing I see is x plus 2 inside the parentheses. That goes back to here, inside the parentheses. If I say plus 2, that is a horizontal shift to the left 2. All right, so the last one, the multiplications inside the 3x, 3 times x. So this would just be right there. I see that 3 and the x. This is just going to be a horizontal shrink by 3. All right, so that takes care of objective 2. We reviewed all the skills for that. The quizzes has been open for that. So if you need, and I haven't checked yet, I'm about to check. If you haven't done last night's, you can finish last night's or move on to the new one. Each one is a grade.
Do you have a missing one?